For today's lesson, we're going to be looking at solving compound and absolute value inequalities. One test used to determine whether a patient is diabetic is a glucose tolerance test. People who are diabetic have a lack of things that are able to process sugar. So it says patients starting the test in a fasting state, meaning they have no food or drink except water for at least 10, but no more than 16 hours, right? The acceptable number of hours H for fasting using an inequality. Well, we've talked about some of these words. At least means that the number of hours has to be greater than or equal to 10. But then it also says no more than 16 hours. So that also means the number of hours has to be less than or equal to 16. So these two inequalities describe the number of hours. What we're going to be looking at today, though, is what's called compound inequalities, which means they're going to take these two statements and make it into one. A compound inequality for the same information would look like this, that H is less than or equal to 16. Then the other number goes on the other side, and we write another inequality symbol in between. Now, we don't want to copy this symbol here, okay? That would be incorrect, because if you look where we just had this, there was the arrow is pointing at the 10 right here. Okay, it's pointing at the 10, the open ends to the H. We need that same thing here. So the symbol actually has to get flipped around to say that same thing. So this statement right here is a compound inequality that states the same information here. Okay, and we're going to be looking at some of those compound inequalities today. All right, so compound inequalities. They consist of two inequalities joined by the word and or the word or. And inequalities are true if and only if both inequalities are true. So like this one says that x has to be greater than or equal to -1 and x has to be less than 2. That would mean if we graph these, you got 1, it'd be a closed dot because it's equal to, greater than would be going this way, less than 2, that's open circle here going this way. The only points that are going to make both of these true are points shaded in between. So this compound inequality would end up being shaded in between both of them. Or inequalities are true if one or more of the inequalities are true. So here they don't have to both be true, just one or the other. Here if you graph these, closed circle at 1 going that way because it's less than. Here open circle here going that way. These ones are shaded out in opposite directions. So basically any points make this true except the ones in between them for this type of graph. You might also see these written in that compound manner. So we want to be able to both solve and graph these types out. So let's look at number 1. They want us to solve this compound inequality for x and then graph the solution. Well, if we're going to solve this compound inequality, we have this 2x plus 7 in the middle. It's hard to graph that having that. What we want to do is get the middle so that it's only x. If it's only x, then we know where to graph it behind. So we want to remove the 7 and 2 from inside there. So just like you normally would solving an algebraic equation, we want to minus 7 here. And we'd minus 7 to the other side. But the problem here, we got two inequality symbols. So not only do we have to minus 7 there, we also have to minus a 7 to this number out here. So now those 7s cancel out. We only have 2x left in the middle. Now we want to subtract 7 from both these numbers. So 17 minus 7 is 10. 13 minus 7 is 6. Okay. Now to get rid of the 2 that's being multiplied, we want to do the opposite divide. So again, not only divide there by 2, but divide there by 2. We want to divide everything by 2. So now our middle is just going to be x. Here we got 5, and then 6 divided by 2 would be 3. So now we know exactly what we should be graphing here. All the numbers in between 5 and 3. So to graph that, on your number line, find where 3 is, find where 5 is. Okay, look at the types of circles. Looks like both of these should be open because we don't have the equals to. Okay, and then we want to shade in the direction. This one's always going to be easy because that one's how we normally see it. X is less than 5. That should be going that way. Um, this one's a little bit harder now. You got to be careful. Don't go the way the arrow's pointing, because if we were just to switch those two things around with the open end to the X and pointing at the 3, it looks like that. That's actually saying greater than. So X is greater than 3 is going this way. We want to shade everything in between those two. So that would be the graph of this compound inequality. All right, let's try another one. This one, do the same thing. Get that middle to equal X. Why don't you pause the video, try this one on your own and see what you get. All right, let's check it. First thing you should have done is add 4 to all the spots. Now we got 3x is less than 15 and greater than or equal to 12. Now I'll divide everything by 3. And we get 4. Here just be x, and here we got 5. Okay, graphing that one out now. Okay, you got wherever 4 and 5 are going to be here. Should be open circle at the 5, closed circle at the 4. It's less than 5, that's going this way. This part right here, if you flip these around, is saying greater than or equal to 4. That's this way. It's all the points shaded in between 4 and 5 make this true, including 4. Okay. This one's not a compound inequality because it's not together. There's this word or in between. If you see that word or in between, it's really like you're just solving two separate inequalities here, and then we're going to graph them on the same number line. So do like you'd normally do with algebra. It looks like we got a -5 here, and we get x is less than 2. Okay, on the other one, we got to add 6, and we get that x is greater than 8. Okay, so now we want to graph both of these separate inequalities on that same number line. So on your number line, find where 2 is, find where 8 is. Okay, and now we want to go through and make sure this is saying what's located on there. This one right here, it's filled in circle because it's equal to. That one's saying less than. Less than 2 is going to be to the left. This one's going to be open circle. It's saying x is greater than 8. Greater than points are out this way. So this graph is one of those or ones. Either numbers less than or equal to 2 make it true, or numbers greater than 8 make it true. None of the numbers in between are going to make this one come out to be true. All right, another place you can see these inequalities is with absolute value. We've talked about absolute value a little bit before. Absolute value of a number is the distance of that number from 0 on the number line. So absolute value of 7 is 7 because it's 7 spaces away from 0. But absolute value of -2 would not be -2 because we're talking about distance. The distance this is 2 spaces away, so that would be 2. Okay, that's just some review. That's not on your note sheet, but a little review. So now what happens if you have something like absolute value of 3? Well, we know from before that means the two things here that could equal 3 is x could be 3, because 3, absolute value of 3 is 3. But also the opposite of this, so -x could equal 3. And if we solve that by dividing, we get -3, because absolute value of -3 is also 3. Okay, so anytime there's a variable in the absolute value, you want to put that inside of there. Same thing is going to be true now with inequalities. Okay, so the two things that could make this true is that x could be less than 4. Okay, or the opposite of x could be less than 4. Okay, so now to solve that other one though, we got to divide by a negative here. So we got to divide by -1. But the one thing you got to be careful of now, we've talked about dividing with these symbols again. These negatives cancel out. This is going to be x. 4 divided by -1 is -4. But the other thing, anytime you divide or multiply by a negative with inequalities means you got to switch the sign. So the numbers less than 4 and greater than -4 would make this true. All right, same if you had one like this. This would mean over here that x could be greater than 4, but it also means the opposite of x could also be greater than 4. If you divide by a negative here, okay, you're going to get -4, but you got to make sure you switch the sign on this one too. So this would mean anything greater than 4 or less than -4 would make that true. Okay, so those types of problems we've done before. Now it's just with inequalities. If you were to graph these out, okay, this is kind of like one of those and ones because, okay, it's going to be anything less than 4, that would be going this way. This is greater than -4, that's that way, so that's anything in between. The second one is one of those or ones. Okay, because we got anything that's greater than 4, that would be going out that way. Anything less than -4, that's that way. So either one of those two sides would make that true. All right. So let's try some more of these absolute value ones here. On 2a, they want us to solve this. So to solve this one, this one's a greater than 1. One clue when you're doing these, if it's a greater than 1, it should probably come out to be one of those or ones, meaning we're going to have our arrows going opposite directions on the graph. Okay, so solve this one. We got 3x minus 12 is greater than or equal to 6. You can add 12, get 18, divide by 3. So we know that x has to be greater than 6, but absolute value, so there's another part to this. You got to do the opposite of what's in here, also greater than 6. So the opposite would be -3x, because this term's going to turn negative. The other one already is negative, so that's going to turn to +12. So now we want to solve this one too. So here we got a -12, and that's going to be -6. Now we got to divide by a negative, okay? Alarm should be going off in your head. Remember, anytime you divide by a negative with these, you got to switch the sign. So it's going to be x is less than -6 divided by -3 is +2. Okay, so graphing that one out, you got 2 and 6. This one is less than or equal to, so we want filled in circle. Less than is going to be going that way. Greater than or equal to 6, that's filled in there too. Greater than is going that way. So that would be the graph of that one. It's one of those or ones. The answer is either over here or it's over here. It's not in between. All right, let's try second one of those. All right, so for this one, same thing. If we solve this, 3x plus 4 is less than 10. Minus 4 divide by 3, we get it's less than 2. But also this could mean the opposite of what's in here could be less than 10. So the opposite would be -3x minus 4 is less than 10. So here add 4, you get 14. Divide by -3. Okay, we're dividing by a negative, so we got to switch the sign the other way. So this one's now going to be this way. Here we just got x. 14 divided by -3. I think we get like -4.666 repeating. Okay, so now graphing this one. Label your graph here. Okay, so the first part saying less than 2, that'd be open circle. Less than points are going that way. X is greater than -4.6. You got to estimate a little bit. 4.6 is going to be right about there. And that's greater than, that's going to be going that way. It's everything in between. All right, last one, a word problem. This says to prepare for a job interview, Megan researches the position's requirements and pay. She discovers that the average starting salary for the position is $38,500, but her actual starting salary could differ from the average by as much as $2,450. Write an absolute value inequality to describe the situation. Let X be Megan's starting salary. So here, to do this one, you got this absolute value inequality. It could differ by as much as this much. So that means it has to be less than or equal to that. And the average is right here. So her average would be in here. Okay, now to solve this one, solve the inequality, find the range. Okay, same thing as we just did. That means solving this out, we'd want to add this to the other side. And one salary that she could have then would be adding that, would be that she could make less than, adding those you get $40,950. So her salary could be as high as that, but if we do the opposite one, remember we got to take the opposite of this now, we could find that. So that'd be negative X plus 38,500 could also be less than or equal to this away. Okay, so now if we minus this value, now I got negative X is less than, that's going to come out to be negative 36050. But we got to get that negative out of there, so divide both sides by -1. That means we're going to have to flip the sign because we're dividing by a negative. And that's going to make that positive. So her lowest her salary could be would be bigger than 3650. So somewhere in between here is what her salary is going to be if it can differ by that much from the average. Okay, try some of these out on your own.